Linear functions is the topic for Chapter 3. In Chapter 2, we were working on linear equations and solving them, and now we're going to go to the next step. We're going to deal with equations in either standard or function form, and we're going to be graphing. So let's start off with our initial type, which is the standard form. Standard form of a linear equation says that ax plus by equals c. C represents a constant, and the ax plus by are two variable terms. When it's in this form, we can easily identify these coefficients. The coefficient of the x would be 4. The coefficient for b would be 3. And the constant in this equation is 6. Now there's going to be times when we're asked to rewrite an equation, and we've done that in function form, but now we're going to do it in reverse, sort of. We're going to be putting things in standard form, which means our x term comes before the y term, followed by the c. So let's take a look at this. The first thing I realize is that I need to move this x term over to the left. So I'm going to use my properties of equality, and I'm just going to add 3x to both sides. I now have 3x plus y equals 4. I can identify my coefficient in front of my x as 3. The coefficient in front of y is 1, and c, the constant, is 4. On to the second problem. Again, I need to move the x term to the left by one inverse operation. We'll subtract it over. I now have negative 2x plus y equals a negative 6. Let's identify the coefficient of x, which is the a value, negative 2. Once again, the value of b is 1, and c is negative 6. Last problem. Let's add the 4x so that we can get those two variable terms on one side. I now have 4x plus 3y equals 7. The a is equal to 4. The b, which is the coefficient in front of y, is 3, and the constant c is 7. Now we're going to be using this standard form to do something called a quick graph in a future lesson. But before we get there, we want to go back and talk about what a function is. We know that a function is a rule that says for every input there's exactly one output. We also talked about writing something in this form, the y is equal to mx plus b form, and how we can take the y and replace it with this name f of x. And all we're doing is replacing y with that notation. Once we have it either in equation form or function notation form, we can set up a table of values. I'm going to take this equation, y is equal to 2x plus 1, and remember, when it's in function form, we can just evaluate one term at a time, but since we're going to be talking about it in the form of a table, we're going to set it up as the equation. I'm giving you the domain, which are your x values. You're going to replace one at a time, and you're going to get 2 times negative 1, which is negative 2, plus 1, yielding negative 1. Let's take a look at a second input value. Let's input 0. When we input 0, our output will be 1. Let's input 1. 2 times 1 is 2, plus 1 will be 3. So when I input 1, my output is 3. And one last one. 2 times 2 is 4, plus 1 is 5. So when I input 2, I output 5. This has created 4 ordered pairs for us. Negative 1, negative 1. Let's go to the graph. Negative 1 and down 1. Our second ordered pair is 0, 1. 0 and up 1. Third is 1, 3. Start at the origin, up over 1 and up 1, 2, 3. And the last ordered pair that we generated was 2, 5. over 2, and up 5. We have now a series of points that we connect, and we've now graphed this line. Let's look at a second example. Sometimes you're going to see that I will write the table horizontally instead of vertically. It's the same setup basically. I'm going to use the same domain values. I'm going to use -1, 0, 1, and 2. So we can do it again horizontally or vertically. Sometimes I use it horizontally to save a little space. Now, domain, if you recall, is your input values. And your input values are your x values. And those could be any values at all because we call those our independent variables. Our range is now the output. And the output is the y values. So we can go ahead and complete a second table now by following this rule. Input x, okay, so I'm going to input x, I'm going to get -1 plus 4. Output 3. Let's input now, because I'm using this rule, y is equal to x plus 4. Well, 0 plus 4 is 4. Let's input 1. And again, I'm not giving you very complex functions or rules right now. We just want to refresh our memory on how to set this up. And now I have, again, several ordered pairs. You will go now and graph those, and you'll form a line. Go ahead and try that. You could do a rough sketch in your notebook. And I have others that we'll practice together. As a matter of fact, start this one, and we'll go over this one in class. The second thing we want to just briefly discuss today is the fact that we have other ways to graph a linear equation. We could always set up a table of values, but we find out that that can be a little tedious. We've got to do a lot of work to get there. So there is 2 other methods, and they're called quick graphs. The first quick graph method is by using intercepts. But what exactly is an intercept? Well, an intercept is a point that falls on an axis. So if I have a coordinate plane, and we label this our x-axis, and this is our y, and we found a point that falls right on the x-axis. That point there is 2, 0. It's a point on the x-axis, and we call that the x-intercept. We're going to find that if we have just 2 points, we can graph a line. If I had another point, and it falls right there on my coordinate plane, the value of that is going to be 0, -4. It falls on the y-axis, so it's a point on the y-axis, and if we think about what that will be called, it is my y-intercept. So if I have 2 points that fall on either the x or y axis, I can connect those points, and I have what we call a quick graph. And that's what we're going to be working on next class.